Hi everyone, I am Durga Devi, Assistant Professor from SNS College of Pharmacy and Health Sciences. In this lecture, I am going to talk about the instrumentation and principle involved in the instrument fluorimetry. The fluorimetric topic can involve molecular relaxation and luminescence processes and the molecular states, that is singlet state, doublet state, triplet state and singlet excited states, and we will be studying about the relaxation process, that is the emission of radiation that can be done in radiative relaxation as well as non-radiative relaxation. In radiative relaxation there may be fluorescence, phosphorescence and collisional deactivation, and in non-radiative relaxation process there may be internal conversion, external conversion and inter-system crossing. The fluorescence actually happens because the fluorescent samples will absorb the light radiation from the source of light and they move from singlet ground state to the singlet excited state, and after going to the singlet excited state they will emit some radiation while returning back to the singlet ground state, and the radiation that is emitted during that relaxation process will be at a longer wavelength when compared to the absorption wavelength. So that is why it is called as fluorescence. Then we have phosphorescence. This happens because in some molecules there may be chances of the electrons to move from singlet excited state to triplet state instead of directly moving to the singlet ground state, and it may be because of the inter-system crossing that can be done in molecules at lowest temperature or in the presence of oxygen, and this movement is considered as a forbidden movement because as you can see the electrons from singlet excited state are moving to the singlet triplet state where both the electrons will be unpaired but they are having opposite spins, that is singlet excited state electrons will have opposite spin and they are unpaired, and the triplet excited state consists of electrons which are unpaired but they will be having same spin. So since this movement is forbidden, it will happen rarely, and after moving to the triplet state the electrons will return back to their singlet ground state by emitting some radiation, and that is called as fluorescence. So we can see here clearly that fluorescence can happen only for 10 to the power of minus 9, 6 to 10 to the power of minus 9 seconds, but whereas the phosphorescence can last up to 10 to the power of minus 3 seconds to 1 second, which clearly indicates that even when the incident light is cut off, the phosphorescence can last. So which means the fluorescence can also be called as a delayed fluorescence, and that is called phosphorescence. So when the incident light is cut off, the fluorescence will also cut off. But when the incident light is cut off, the phosphorescence can last for some duration of time because it is called as a delayed fluorescence, and its time is more than that of the absorbance. That is, the absorbance time is 10 to the power of minus 15 seconds. And we can see the instrumentation of fluorimeter. The instrumentation involves the light source. The light source can be a xenon lamp or a mercury arc lamp or tungsten lamp. The light source will provide the radiations that are necessary for the molecules to excite. So they will provide the excitation light, and the excitation light is filtered through the excitation monochromator or primary filter. Their prime purpose is to allow only the UV radiation to pass through, that is the excitation wavelength, and after passing through the excitation monochromator or filter, the light radiation will reach the sample cell or cuvette. The sample cell will be filled with our fluorescent sample. Then after the emission happens, while the electrons move from triplet state to singlet ground state, they will be filtered again another with the help of emission monochromator or secondary filter. Their prime purpose is to allow only the visible radiation to pass through, and the visible radiations are immediately detected with the help of a detector, and there are different types of detectors, but here I have mentioned the photomultiplier tube. So this is a simple instrumentation of fluorimeter, and the principle involved here is you can say in ground state, that is S0, the absorption happens. The molecules that are present in our fluorescent sample will absorb the light radiation at their shorter wavelength, and after absorbing the light radiation they will go back to their singlet excited state. Okay, after absorbing the light radiation they are going to the excited state, and since the excited state is not much stable, they will return to the singlet ground state by emitting the radiation, and that is called as fluorescence or emission. That will happen at a longer wavelength. So this is the simple principle behind fluorimetry, and with the help of this instrument we are going to measure the fluorescence produced by our sample. Thank you.